I think we can begin. We can begin with you. We have all the audience here waiting, and we have Zoom translation, and it seems to be working even with my English.
Okay, I'm going to hit share, and you may see the introduction to my talk. Okay, and we're talking about the delays that are keeping us from gaining access to regenerative medicine technologies. Those delays, of course, cause us to die prematurely. Now, for those who don't know me, I founded a group called Life Extension back in 1977. We've since grown to be the world's largest consumer-based anti-aging medical group. And what I'm going to describe initially is, of course, our problem, and that is in the United States and in the EU, basically over 7,000 people dying every single day, most of them dying from age-related ailments. And the major cause, again, this degenerative aging process that makes us, unfortunately, ill as we grow older and eventually terminates our lifespan. And one big solution is not the science, it's simply breaking down the bureaucratic barriers that are stifling our regenerative medicine research projects. We've got a number of human studies we want to initiate, and our FDA is not letting us do it. We find even in other countries, a clinical trial is not always easy to initiate. You've got to get the government to approve it, and they don't know anything about the technologies that we're utilizing. So what we want to do is break down the barriers. In the United States, it's the FDA and Congress. In Europe, they've got their own bureaucracies that impede aging research, impede cancer research. And the result is people die, even though effective therapies already exist to treat their underlying condition. And just a couple weeks ago, a study came out in monkeys using metformin to slow down the aging process. And what they were able to find is metformin prevents brain atrophy. It elevates cognitive function in aged male primates, about as close as we can get to humans. And it was shown to slow aging across a diverse range of monkey tissues using epigenetic age measures. And the metformin supplemented monkeys, they had neuronal aging delayed and even improved neuronal synthesis where they were producing more brain cells. So we've got systemic geroprotection. And to break down this study a little bit further, the epigenetic age in the liver of these monkeys that were treated with metformin compared to the control group over 3 years younger. This is what we want, a reduced epigenetic age. The lungs were 5 years younger in epigenetic age. The brain, frontal lobe, 6 years younger in metformin supplemented monkeys compared to the placebo group. And also protein age appeared to be over 6 years biologically younger. And this deals with our entire body. We're comprised of proteins. Those proteins, unfortunately, age and eventually cause us to die of a fibrotic or other type of condition. And in addition to all these benefits, the metformin supplemented monkeys, and this again, only a couple months ago, this study came out, they reduced markers of cell senescence. We know our bodies accumulate a lot of senescent cells with aging. It kills us, and enhanced neuronal regeneration of the brain. So this landmark study came out in July 2024, helped to validate the long-standing position that many of your viewers right now are engaged in, and that is they're taking metformin whether they have diabetes or not. And the authors of this study concluded that metformin, at least in monkeys, can postpone the age-related structural deterioration in the brain and other organs and improve cognitive function. That's something we all want to see, and we're glad to see this study came out. It published just 3 weeks ago, actually, but we got word of it back in July. It was coming out, and it was going to be very favorable for metformin, which is very good because we don't have time to delay human research. And the scary part of metformin is that while we've got tens of thousands of our supporters taking it, we don't have any clinical trial in non-diabetics to validate if it has true anti-aging properties in people. We want to get those clinical trials going. And by way of example, metformin was approved in England in 1957 and shortly thereafter in countries around the world. It wasn't until 1994 that the FDA in the US approved metformin, and that 37-year delay caused millions of American deaths. But what's really scary is here we are 67 years later, and almost nobody in this world, except people that belong to groups like this, understand metformin has anti-aging mechanisms, properties that can slow down and reverse certain aging processes. And what got us interested in metformin? Back in 1995, a study done in Britain showed that type 2 diabetics taking metformin had a 32% reduced risk of diabetic complications, 42% reduced risk for diabetes-related death. And what fascinated us the most? A 36% reduced all-cause mortality risk, meaning the diabetics taking the metformin, they were dying at a 36% reduced rate. This is impressive. This is what we seek to do with every technology we engage in. So in March 1995, we added metformin to our long list of medications available in Europe that were not available in the United States. You see metformin on top, but you also see ribavirin, you see Permixon, that's a drug in Europe sold with saw palmetto, sometimes other ingredients in it. We had to be the first ones to introduce that into the United States because our government, unfortunately, was too slow in recognizing the value of many of these compounds, many that are now sold over the counter. And then in 2017, study came out in JAMA, Journal of the American Medical Association, and it showed that people who were not yet diabetic, it reduced their risk of progressing to diabetes by 31%. And if they initiated metformin under age 60, it reduced diabetic risk by 58%. So this helped validate our long-standing position starting back in 1995. Metformin was a good drug to put in your body every day to slow down pathological aging processes. MD Anderson did a little study with people with diabetes who were taking metformin as opposed to other anti-diabetic drugs. The metformin group had a 62% reduction in pancreatic cancer risk. Anyone knows about pancreatic cancer, it's something you don't want to get because it's very difficult to treat. Almost everyone dies within 1 to 2 years. So anything that lowers pancreatic cancer risk, we like that. So when we see this kind of research, we put it on the front cover of Life Extension magazine. We make it headline news, the anti-cancer effects of metformin. People who are using metformin are likely reducing their risk of multiple types of malignancies. We're very happy about that. And this study came out in 2017 showing if you have colon cancer and you need typically surgery, all kind of other conventional techniques, if you happen to be taking metformin, you reduce your risk of occurrence almost 5-fold. Metastases cut in half. 5-year survival improved, and deaths. Well, if you're on metformin and you've got colon cancer, this is typically advanced stage disease. Well, 48% die of metformin, but if you're not taking metformin, 76% of the colon cancer cases in this study that they died. This is a huge survival advantage. We know metformin boosts AMPK. We know it indirectly inhibits mTOR. These are specific anti-cancer mechanisms, but there's also other mechanisms, including better glycemic control, all beneficial for cancer. So November 2015, the world's first study to see if humans can live to be a real long time of age. This was published in 2015 around the world. 2016 made the front page, the Wall Street Journal, that a drug, and this drug happened to be metformin, was going to be studied to see if it could delay aging in senior citizens, older people who were going to start and see if they couldn't live longer by taking metformin. Dr. Barzilai, he's doing great work. He got a lot of publicity, and he felt that his study would show metformin could extend healthy lifespans in people. We were all excited about that. CBS News reported on Dr. Barzilai's work, as did many other media, and they talked about the fact of Dr. Barzilai's opinion that aging can be delayed, it can be stopped, and it can be reversed in several ways. We were all excited here, a new trial on metformin, so we could see how well it really works. Well, here's the scary part of it. September 2024, we have not found a single clinical subject enrolled in his study. If there is one, we can't find it. We're making telephone calls, we're checking with the FDA, and it seems like for various reasons, he has not been able to launch this study 9 years after he announced it, 9 years after he had some funding, a lot of media interest, lots and lots of study subjects wanting to volunteer, and that study hasn't happened. And I'm thinking, how many other drugs are out there in which clinical trials are not occurring? We've got the FDA, unfortunately, having these mandates for safety, as they call it, and even studying a drug like metformin in non-diabetics, they were concerned about some of the safety issues, and they torpedoed one of our trials that was going to be multi-interventional using metformin, rapamycin, NAD, and a senolytic, and eventually deprenyl, young plasma, and of course transcription factors. We were looking to put everything in to a cocktail to enable old people to grow younger. FDA said no. But as it relates to metformin's delay alone, JAMA 2019 showed that diabetics taking metformin, they reduced their cardiovascular risk in a major way. And we wanted to calculate, well, what happened between 1957 and 1994 when Americans were waiting? It turns out about 4 million American diabetics prematurely died of cardiovascular disease because of the delay of metformin alone. That's a scary number because it equals the toll of all the wars the United States has ever fought. The FDA delay, which was really not an FDA delay in this case. There was a lot of other bureaucratic reasons why metformin was delayed in the United States. But it's not just metformin. Ribavirin, a broad-spectrum antiviral drug, discovered in 1972. We recommended it to our members back in 1983. In 1991, the FDA brought criminal charges against us for promoting the use of an unapproved drug. Ribavirin at this point, by the way, was approved around the world, except in the United States. And then the FDA brought criminal charges against the company founder. ICN owned the patent for ribavirin. They were getting impatient with the FDA and started going to the media talking about how well it worked. Well, that means a jail sentence in this country. FDA does not like people talking about drugs they have not yet approved. Well, 1998, after a lot of work we did going on national TV shows talking about the multiple benefits of ribavirin, especially as a treatment for hepatitis C, they approved it. They approved it in 1998. Meanwhile, Saul Kent, myself, Bill Faloon, the founder of ICN, and potentially others, had to go to jail because the FDA didn't say ribavirin was ready for approval yet. And this tragic outcome with hepatitis C alone, about 60,000 Americans died waiting for ribavirin to be approved. It's used in conjunction with alpha interferon plus ribavirin as a treatment for hepatitis C. Nowadays, Sovaldi and Harvoni, those are drugs used to treat hepatitis C. They work much better. Those are newer drugs, but one of them still relies on co-administration of ribavirin for optimal benefits. So this is a good drug that took way too long to approve, but that's the history of medicine. 400-year delay in scurvy being proven to be a vitamin C deficiency or a citrus deficiency. All of this evidence that was brought up, and unfortunately improper trials and just different types of prejudices caused a 400-year delay before scurvy was recognized as something you could prevent and treat with vitamin C containing fruits. Antibiotics. Penicillin discovered in 1928, published in 1929, not widely available until 1946. And bear in mind, back in these days, the leading cause of death, well, bacterial infections, tuberculosis, diarrhea, pneumonia, mainly from bacteria. You had a cure for it, but people couldn't get access to it because it wasn't even made available widely until 1946. Now, our Human Age Reversal Project has over $1 million in an interest-bearing broker account, and this money has been dedicated to do a multi-interventional clinical trial where we introduce metformin, rapamycin, NAD, deprenyl. We look at senolytics. We look at young plasma fractions, exosomes, and eventually OSK, and that eventually can only be a year or two away. FDA won't let us do a multi-interventional clinical trial. We're searching the world to find out where we may be able to do it, but the ideal place to do it is in a modern country with lots of good blood testing labs, lots of good medical technology available to assist in that trial. So we continue to have bureaucratic roadblocks that are keeping us from enabling people to save their lives with currently available technology. Now, this particular drug is available in Europe right now, thymosin alpha-1. not available in the US, but this is an immune boosting drug that also suppresses deadly inflammatory reactions that occur during sepsis or during any type of serious illness. Now, in 1981, we dedicated most of our newsletter, Anti-Aging News, to the benefits of thymosin. Wasn't approved yet, but we were encouraging the government to approve it. And the FDA reviewed one clinical trial. They decided that it was not worthy of their approval, and it was rejected. And the company could not do another clinical trial. They simply ran out of money. Well, starting around 2019, the medical community began looking at thymosin alpha-1 again, starting to reappraise its value. 2019, 2020, 2022, 2023. All these studies, by the way, are available on our age-reversal.net website. I'm just going through them fast to show that the scientific community is recognizing the value of thymosin alpha-1, and yet Americans still don't have access to it. The good news is Europeans do, and you'll be reading a lot more about that in our Life Extension magazine. And again, sepsis, that kills 300,000 Americans a year, and a lot of that is the hyperinflammatory response that people undergo when having sepsis. Thymosin suppresses unwanted inflammation and boosts a number of immune functions that could maybe cure half of these sepsis patients based on people that we've talked to. So here we are 42 years later, a drug that was actually invented in the 1970s, not available in the United States, not available here. And we're encouraging people who are aging to death from a standpoint of immune senescence to consider following our thymosin alpha-1 protocol, which will be about 25 units 3 times a week, has to be injected. And you guys in Europe, you've got it made. That drug is approved, and you can get it in Europe. In the United States, we really can't, because it has to be shipped in a cooled way. If it gets overheated, it's a peptide, it just disintegrates. It is injected, by the way, it's not a pill. So what's happened in early 1994? Well, I could talk for a long time about that, but this year has been unprecedented in the number of published studies showing aging can be reversed. In this first study, exosome-rich young plasma, it cut epigenetic ages in half, improved overall health. That research is now advancing into dogs. Preliminary evidence is it's working as well in dogs as it did in the rats. Very, very good evidence, because this particular dog, beagles, if it works in them, I've been told by pharma people that if a drug works in beagles, it often works in people. And that was using exosome-rich young plasma. Second study simply used young plasma, injected every other week into old rats, and that increased their median lifespan, the human equivalent of about 7 years. A major way of demonstrating the potential value of young plasma in reversing our epigenetic age, enabling us to grow older. Most exciting study published this year, OSK. These are 3 out of the 4 Yamanaka transcription factors. They reversed epigenetic age, improved overall health, extended remaining lifespan over 100% in old rats. That research is now moving into old monkeys, and that's a trial that I am funding myself to see if we cannot take old monkeys and biologically reverse their aging process so that they behave like young monkeys and their DNA methylation patterns resemble young monkeys, and their clinical measures of health, their kidney, liver function, their lipids, everything related to inflammation, insulin sensitivity. We want to see that go in reverse the way it did in the old rats and the way it's doing in the old beagles right now. So our group is aggressively moving research forward into monkeys and additional studies in old rats to see if we cannot perfect the use of OSK to enable us to grow biologically younger. Now, when OSK-M or OSK is injected into old animals, it systemically reverses their aging. This was demonstrated in 2022 by the Salk Institute. And then 2024, an even more impressive study using cyclic induction of OSK. Wow, 100% increase in remaining median lifespan. That doesn't mean you live 100% longer from the date of birth. It means that, well, if you were supposed to die at a certain age, let's say 75, you may make it up to 88, 90 years of age with improved health, profound age reversal in the heart and liver. If you've got a failing heart, could be that OSK is able to regenerate your heart. We don't know that yet. We need to study it. And then these same scientists did a study with human cells in vitro in a petri dish, and they were able to reverse aging of human skin cells. remarkable research. So what's happened is a relatively slow pace of advance here. 2006, the cellular reprogramming using Yamanaka factors demonstrated cellular rejuvenation that had never been done before in history. They demonstrated it in 2011. They took 100-year-old human cells and reversed aging in those cells also, all the way back to the embryonic phase. 2022, systemic administration of OSKM, reversed aging in live mice without side effects. 2024, confirmatory research shows that old mice, and now we're hoping to move that into old monkeys within the next 2 months, and then humans, and there are some humans self-experimenting with this. I don't advocate it, but that's how desperate some people are as it relates to the aging process. But to emphasize, the prior doctrine in biology is that an old cell could never be reprogrammed back into a younger cell. Well, it couldn't be unless you had Yamanaka factors. Those reprogram old cells back into a younger cell. Now, our life extension group have been publishing since 1977, 1980, data about what people can do to delay and reverse aging. We lay out different dosage protocols, and we need to study those now in a major controlled way, and we need to get the FDA to allow us to do that kind of work or somewhere else to let us do fundamental research that most of your listeners are already engaged in. We'd like to research it in a systemic way so we know what's going on. So this entire presentation is available at age-reversal.net in a rather elongated form. And if there's any delays in some of the slides, we'll have them up in the next few days and that sort of thing. So that's most of my presentation. Now, if you want me to go on, I've got other scientific news to report, but I thought I might be running out of time, Jose. So what would you like me to do?
Bill, that was a fantastic presentation. A tour de force with all the technologies happening. But let's get to the time, and we have a couple of questions from the public before we move to Brian Johnson, who has also joined the discussion. So, first question. When do you think that we can have the first rejuvenation therapies for the public in general? And which therapies are you most excited about?
We feel in the next 2 years, we will be able to study OSK transcription factors in older people, assuming our primate research yields robust results in demonstrating age reversal, longevity extension compared to the control group. I'm personally spending millions of dollars on this research because I don't want any delays. I want to see if we can make old monkeys, young monkeys, and if we do that, we've got thousands of people who want OSK. We're begging them not to use it yet. Let us see how well it works in the monkeys at varying doses. So when we do our first trial with OSK in humans, we can at least have some primate data to help them out. So as soon as 2 years, we may be doing research, and anyone who's interested in that should register at our website and indicate they want to be a clinical trial participant.
We have another question, and also one for Brian Johnson, but I will ask this question to you as well. How long do you think that you will live?
How long will I live if technology does not evolve rather fast? I'll live to be 90 to 100 if I'm lucky. And if I'm lucky, I'll be stricken down rather soon. So this technology is the key to all of our longevity. If it moves ahead fast, we get to live longer, if not forever. If it's delayed, we die.
Okay. Well, that's because you are a bit older than me or than Brian Johnson. But do you think there is a cutoff age, like 60 or 70?
The good news is this OSK research was done in 77-year-old equivalent mice. So that's very encouraging. And there's some evidence that even an older person who adopts healthier dietary practices can markedly extend their lifespan. So as far as we know right now, there's no upper limit, including that evidence where they took 100-year-old cells in vitro and rejuvenated them back down into an embryonic phase. And you don't have to go that far. We can just do partial cell reprogramming and bring, let's say, a 100-year-old cell back down to a 28-year-old age, and then theoretically do that systemically so that an in vivo person can grow biologically younger.
Beautiful. And one final quick question. What is a better option for longevity for an individual? Lifestyle or investing money and time in research?
At this point, you've got to take care of yourself. And I think most of the people in this conference understand what a healthy diet is compared to a deadly diet. So healthy lifestyle, healthy diet, the right supplements, the right medications, frequent blood testing, all kind of diagnostics. Don't die from something that we can pick up now and cure. Stay alive. We are helping to move the technology forward, as is people like Brian and some of the billionaires in Silicon Valley. We've got people putting big money into aging research. So please take care of yourself. Right now, I've got money in the bank to do a multi-interventional trial. Can't spend it. I will be spending my own money on the monkey trial. But my commitment to those donors was this would be a human trial. I use that money for the Human Age Reversal Project. And when we need money, we'll ask for it. And people have been very generous with us. But right now, we're good. If there's other charities that could use that money and doing good work, maybe they could use that money.
Beautiful, beautiful way to finish.